Students, will start with the next topic, energy. Okay. Now, life is impossible without energy. The sun is the largest source of energy to us. Okay. Now, the word energy is often used in our daily life, but in science, excuse, we give it a definite and a precise meaning. Okay, as we gave the scientific meaning of work, there's a scientific meaning of energy. Okay. Now, for example, suppose there is an example of a fast moving cricket ball which hits a wicket. Okay, and the wicket gets thrown away. Okay, like that we have got so many examples. Okay, one more example you want, you can tie a hammer. When you are hammering a nail, the nail gets into the piece of wood. Okay, so it is driven inside the piece of wood by the hammer. Okay, for example, you have a toy. When you wind up the toy, then after the unwinding takes place, the toy starts moving. Another example is of a balloon. When you fill the balloon with air, you press it gently, again it will come back to its original shape. But if you press it more, okay, and the force is more than what you're just pressing it gently, it will just burst. Okay, now all these examples tell us that when an object has a capability to do work, okay, that means it has energy. So whenever a work is done by an object, that object will possess energy. Okay, the object when does the work loses energy. Okay, so whenever you are doing some work, you are no bound, you are going to lose energy, and the other object on which you have done the work will gain energy. So you have to understand this. Now, how does this object with the energy do work? Now, whenever an object possesses energy, it will exert the force on the other object. Okay, for example, hammer. Now, because the hammer has got some energy, it will exert on the nail. Okay, so whenever an object possesses energy, it exerts force on the other object. So what happens? The energy is transferred from the former or the first object to the second object. And the second object then may do the work, whatever is the work, it may move or whatever, as soon as it receives the energy. Thus the first object, because it had the capacity to do work, then only the second object can do the work. This implies that any object possesses energy, then only work can be done. So the energy possessed is measured in terms of the capacity of doing work. So how much ever energy, that much work will be done. And the unit of energy is therefore same as that of work. And we have already seen what is the unit of work. Previously it is joules. Okay, so for energy also it is measured in terms of joules. So what is 1 joule? 1 joule is that how much energy is required to do 1 joule of work. That is the measurement of the energy. Sometimes you have to use a larger unit, like you have to use kilojoules. Now what is a kilojoule? Kilojoules is equal to 1000 joules. So 1 kilojoule is equal to 1000 joules. Now there are different forms of energy which we have already seen in lower classes, like mechanical energy, potential energy, kinetic energy, heat energy, chemical energy, electrical energy and light energy. All these forms we have already studied in the lower class. Okay? Now we have here a scientific information about Joule, who was a scientist on why we have named the due to his contribution in electricity and thermodynamics, we have named this unit Joule after the scientist Joule. Okay. Now kinetic energy will start tomorrow. Okay. So thank you. I end the class today.